Hello and welcome to this presentation on atoms, and in particular we're looking at atomic structure. Okay, this is a diagram you may have seen before. This is the typical atom. You've got the nucleus there, bits in there and bits on the outside as well. Let's try and find out a bit more about these bits, shall we? So first of all, nucleus. Now nucleus is, as you can see here, in the middle of the atom. Okay, it contains protons, which are the greeny coloured ones here, and neutrons, the orangey ones. There's no relevance at all to the colour, that's just where it comes. It has positive charge because of these protons. These protons here, each one carries a positive charge. And really important thing is that almost the whole mass of the atom is concentrated right down there in the nucleus. Now, surrounding the nucleus, we've got the electrons. Electrons move around the nucleus, okay, and they are negatively charged. So where the protons are positive, electrons are negative, and notice a neutron has no charge. Okay, electrons are tiny, but they cover a lot of space. Most of the atom consists of empty space. In the middle there is the nucleus, then whizzing around you've got these electrons. The volume their orbits occupy determines how big the atom actually is. It's not the nucleus, it's the orbits of the electrons. They determine how big the atom actually is. And they've got virtually no mass. In fact, compared to a proton, for example, you need 2,000 electrons to weigh the same as a proton. And they occupy, as we said, shells or orbit levels as they're called, okay, or energy levels around the nucleus. And these shells and the movement of electrons explain the whole of chemistry. Okay, let's look now at the electron shell rules. First of all, number one, electrons always occupy shells or energy levels. You can see them here. There's the first one, there's the second one, there might be a third one, and so on. The lowest energy levels are always filled first. So in this diagram here, the first two electrons go in the first orbit, then any remaining electrons go in the second orbit until that's full, and so on. Only a certain number of electrons are allowed in each shell. Now the first shell can only hold 2 and it's full. The second shell can hold 8 and that's full. And the third shell again can hold 8. In fact, if you go on and look at chemistry at a high level, you find it can hold 18. But for all our intents and purposes, the third shell can only hold 8. Now atoms, this is a statement, atoms are much happier, so to speak, when they have full electron shells. Okay? In most atoms, apart from the inert gases, the outer shell is not full, and this makes the atom want to react. So, how do we know how many electrons, protons and neutrons there are? For that we need a little bit of information. We need to know about the atomic number and the mass number. These are the two numbers we need to know, and we can find these, if we're never quite sure, in our periodic table. Here we have the symbol for sodium, and it's got two numbers, 23 and 11. Now 23 here refers to the mass number, and this is the total number of protons and neutrons, whereas 11 refers to the atomic number. Sometimes it's called the proton number because it tells how many protons there are. So some books will describe this as a proton number. We're going to stick to the atomic number. Now the atomic number tells you how many protons there are. Also, it tells us how many electrons there are. To get the number of neutrons, just subtract the atomic number from the mass number. So 23 minus 11 tells us there are 12 neutrons in the nucleus. The mass number we see here is always the biggest number. You're never quite sure. The mass number is always bigger than the atomic number. It tells you relative mass of the atom. As we said, most of the atom consists of the nucleus with protons and neutrons, which is why it's called the mass. This is where most of the mass is. The mass number is roughly double the atomic number, but as you go through the periodic table, you'll find this isn't always right. Okay, which means there's about the same number of protons as neutrons in any nucleus, but that can vary. So in this atom of sodium, we've got 11 protons, 11 electrons, and the difference between these two here tells us we've got 12 neutrons. Okay, well thanks for watching this video, and I hope you now understand more about the structure of the atom.